That's why we wrote the book, was to have a good examples for these practitioners to say, what problems can you solve using AI? And our hope is people can read these chapters and say, oh, if you solve this, I could potentially solve my problem too.
I'm Raj Kumar, and you're in the DevX Book Club. Maybe you're a global development nerd like me, maybe you work at the UN or an NGO, or maybe you're just excited to hear from some of the world's leading authors on the most important issues of the day. Either way, you're in the right place. Grab a snack, get a comfortable seat, and don't worry if you haven't read the book, you're very much welcome. Get ready for our discussion. If you've been following our coverage, or really any coverage anywhere, you know that AI is the topic that everyone's talking about. In the global development space, a lot of that conversation is about how AI can be used to fix society's most pressing issues like access to healthcare, human rights, and climate change. My guest today, Juan Lavista Ferres, is the corporate vice president and chief data scientist at Microsoft's AI for Good lab, and the co-editor of the recent book, AI for Good: Applications in Sustainability, Humanitarian Action, and Health. AI for Good isn't about how artificial intelligence can be used in theory. It actually offers several concrete examples of how it's being implemented right now. From tracking online misinformation to monitoring whales from space, the book shows the incredible range of AI's uses and the power it has to change how we do good. It's good to get to meet you.
Pleasure to meet you again. We met, I think, in Davos.
That's right. Good to meet you again, and good to, get to say congratulations on the book now that I've actually read it.
Thank you.
It's an achievement and fantastic timing as well. Maybe we can just dive in. I was really fascinated by your personal story, which comes through just a little bit in the book, because this is really more of a technical book that is designed to, I think, show what's possible when it comes to AI in the fields that this community listening to this podcast are very focused on, things like health and sustainability. And, there was actually, the timing of the book is great for all the interest that there is in AI, of course, right now. But it's even funny to me that it came out, and you and I are having this conversation right now, just a few days after Jon Stewart, the comedian who hosts The Daily Show, did a bit about AI, kind of making fun of AI, saying, everyone says it's going to change the world, but really they're designing it to do all of these very day-to-day pedestrian things. And just after hearing that bit, I looked at your book and saw, wow, actually there are a number of things we could say to refute that commentary from Jon Stewart. But before we get into what some of those things are, Juan, I thought it'd be interesting to hear a little for our audience about your backstory. You're a computer scientist. You're a chief data scientist. You started coding at the age of 8. You have a long career as a computer scientist, but you also spent a significant stint at the Inter-American Development Bank. You're from Uruguay. And so you have a bit of an unusual background. I mean, it's not as though you just woke up one day and you're running the AI for Good lab out of nowhere. You're somehow connected to these issues. So I thought maybe you could just start with a little bit about that connection and your backstory, how you ended up at the Inter-American Development Bank, why you care about issues like health and sustainability and development.
I was born and raised in Uruguay. I grew up in a farm 3 hours north of Montevideo, the capital city of Uruguay. I had the luck that my parents gave me a computer. It was a Spectrum clone, actually. It was the Brazilian version of a Spectrum clone. That's 48 kilobytes. And I learned how to code with that computer. I became enamored with the power of coding, even though that was a very basic, relatively basic coding.
Literally basic, right?
Literally basic. It was literally basic. And I loved the idea of coding. And that's what drove me to study computer science. And in 2001, I had the opportunity to go as an internship to the Inter-American Development Bank. The Inter-American Development Bank is similar to the World Bank in many ways, but with a focus on Latin America and the Caribbean. My job there was very different to everybody else's job there. Like, I was helping economists work with data. There was no data scientist at that point, but even within computer science, I love the idea of working with data. I think in '99, I saw for the first time, a machine learning model, an AI model basically. This was when AI wasn't cool. And I also became completely enamored with the power of algorithms that could learn from data. So I was already passionate about data, but then I saw the power of using algorithms to learn from data and to learn how to code from data. Basically, what these algorithms are doing is converting data into code. That's drove me to continue working in that space. And I did some of the early machine learning models as working in the IDB. I convinced a group of people to use AI to help them predict which of these projects were going to have high risk of not being developed on time. And I saw the power on both sides. I saw the power of organizations like the IDB to help governments and help nonprofits and help countries with programs. Part of my job, I was working for the Office of Evaluation and Oversight. That was my job was helping economists learn whether a project had impact or not. Basically, learn how causality. You were giving a huge amount of money to these countries to do projects, and you wanted to understand whether they were having an impact. So I learned a lot about causality from economists. Typically, computer scientists do not understand causality. I learned a lot from causality from that. I moved to Seattle to create a startup. It was called alerts.com in 2008, actually. Likely wasn't the best year to create a startup. And we ran the first round of funding, but we had to do the second round of funding around October. This is when Lehman Brothers came down. There was no money at
Not
all.
the moment to ask
Not
for money
not
from
the moment.
investors.
I learned the hard way that wasn't the right time to ask for money, and because of that, I ended up working at Microsoft, and I ended up working in Microsoft in actually randomized control experiments in Microsoft. What a lot of people in computer science understand as A/B testing. And we were the first group. We were the group that basically wanted to run A/B testing at scale at Microsoft. That group later on got reorged into Bing. I became part of Bing. Was running like data mining, what was now later on called machine learning, but at that point people called it data mining. I became part of that team, and through that, there was one of my colleagues, a great friend of mine, had lost a child to SIDS. SIDS is sudden infant death syndrome, and he was doing an amazing job raising awareness about SIDS. And I told him, like, in order to raise awareness, he was doing hiking. I'm not a hiking type of person. It was like, instead of doing that, can we actually try to help the researchers with data? And he put us in contact with the people from Seattle Children's Hospital. That is an amazing hospital here, using an open dataset that CDC has, that has every single child that was born in the US and a cohort of 1 year to understand whether that child survived. And this is an amazing data set. And we use machine learning models, we use AI models to try to predict whether these children were higher chances of dying from SIDS, and show some of the results to researchers at Seattle Children. Some of the learnings they knew, and some of the learnings they didn't know. And that's the day when I realized that there was a lot of things that we could do to help in health or in general from an AI for good perspective. And at that point, my dream was, well, eventually I will retire from Microsoft and I will be able to do this. And but through that presentation, through that project, at one point we went and we presented this to Brad and to the SLT and to Satya, and they loved
That's
the
Brad
idea.
Smith, of course, and Satya Nadella, the president and the CEO
Yeah,
of
sorry,
Microsoft.
Satya and Brad Smith and part of the SLT, and we presented it to them, and they loved the idea. And just a few months after that, there was my manager at the point moved to report to Brad, and I became part of that team running AI for Good and creating the AI for Good lab. And that became my full-time job of using AI to help organizations around the world. And I think that even though I didn't design my path, like that was kind of a random walk, like working in the IDB, working in the technology sector, I learned a lot of things that work and a lot of things that didn't work. I learned how to work with organizations like the IDB, and that requires a special set of skills. Part of our success is to be able to work with organizations and to understand their problems and translate their problems into AI problems. So I think that that's something that's a lesson in life that I learned how to work with those projects.
Yeah, that comes through a lot in the book. As I say, it's somewhat technical, but it's not just technical in terms of, the tools of AI, but also the processes that need to be used for AI to be applied to the kinds of problems that people face in the global development space. And I think it's interesting. We think about your career. There's different ways that computer scientists come at these problems. Some come doing basic research and trying to develop, new tools from scratch. And you come at it, I think, more from the application standpoint, whether it was inside the business, looking at the Bing search engine and how to optimize it for advertisers or users, or whether at the IDB, how to get more value out of the data the IDB was collecting. Am I right to say you've kind of come at this as a practitioner in a lot of ways?
We are applied researchers, and we are very proud applied researchers. I think that this is one of the things that the world needs more, is people trying to look for, like, it's not that we have enough hammers out there, but there's a disproportionate amount of people trying to build new hammers versus those that want to use the hammer to go solve problems. And I mentioned this in the book, but as humans, we are addicted to complexity. We love complexity, correct? Like, we like complex projects, we like complex things. I mentioned this is like, we put a person on the moon before we added wheels to our luggage. That's a great example. Like, and there's nothing wrong about putting a person on the moon, for sure, but clearly we need more people looking about very simple solutions that can have an impact. And those are usually not the ones that sometimes we're going to be seeing as the most sexy problems from publishing a research paper, but certainly the ones that will have a real world impact. And those will not be the complex solutions. Like, not a single complex solution will work in a production setting. This is not something that I realized, and also became kind of frustrated with the world in some way, was that a lot of these problems are solved in theory, meaning that there is a research paper that says that the problem was solved. And sometimes because of that, people just forget about it, how that problem is solved. It's not solved until you see this in a production setting, working in production. And there's a huge distance between solving a problem in a paper and solving a problem in production. And if you ask me, that is where 90% of the effort needs to go. And that's the most challenging aspect of the projects. So certainly we are very passionate about applied research. It's hard. It's hard, it's hard to solve these problems, but even harder to do the knowledge transfer, to work with the right organization, the right subject matter experts, and then eventually see this in production setting. That is hard, but certainly worth the effort.
I wonder if it's gotten easier. I'm thinking about how you were founded in 2019, and I'm not sure when OpenAI first started or when you first started using their tools. Obviously, Microsoft's an early investor and supporter of ChatGPT. But I wonder, has the ubiquity now of these large language models, these kind of general purpose ones, they're not specific like the kinds of applications you talk about in the book, but has that changed the landscape for you beyond just the raised awareness of the opportunities?
It definitely changed the landscape, because there are many problems out there that we couldn't solve. We started using GPT-2, actually. That was the early version that we started working with them. That was even before there was or even before, or right around the time that Microsoft started working with them.
So that was like 2020, maybe?
2020, I think. That's when, yeah, I think it was 2020 when we started working with some of the large language models they had. Uh, because a lot of the process required natural language processing. We were not using it like people use it today as ChatGPT. We were using it as, given the amount of text, I need to understand what is the text, what is in the text, what is not, and I need to be able to answer questions from that text, basically. So it was kind of similar, but not it was not like an environment like ChatGPT type of things. It was more like having like an API call from text to get answers. And we saw very, very early the power of these models, even though they were much less powerful than what GPT-4 is today, but certainly more powerful than other large language models that we've been using before. But I think that the landscape changes because the bulk of human knowledge is stored in unstructured data, unstructured text, correct? So the open web is the most important data source we have in the world. That's where majority of the human knowledge is stored. But until we have large language models to be able to work with that data, it was not possible to convert that data into something that we can be used to solve problems. Not all the problems are going to be solved through large language models. Majority of the work, if you look at the book, majority of the work there is not using large language models. However, because we now have large language models, we are kind of revisiting problems that we couldn't solve before. And now we can solve solutions that much faster than before. So certainly it's an amazing new hammer that we have. It's not going to solve all the problems. Sometimes I see people trying to use large language models to solve problems that we could solve with just a few lines of code, much more efficient. So sometimes it's just a big hammer, but it's certainly a really powerful hammer. And certainly we're using it for many problems. And again, for me, what the important thing was we are revisiting problems that we couldn't solve before, that now we think we can solve.
Are you looking for the inside story on what's happening at organisations like the World Bank, USAID or the Gates Foundation? Then you need to be reading DevEx Pro. I'm Jessica Abrahams and I'm the editor of DevEx Pro. Pro is DevEx's premium news subscription where our expert reporters and analysts take you beyond the headlines, deep into the trends and institutions shaping the $200 billion aid industry. As well as all our news, you'll get access to conversations with global development leaders, resources to help you grow in your career, and a subscriber-only newsletter full of insider news and tidbits. See for yourself by getting a free trial today at devex.com/pro.
It seems like a lot of the use cases where you're looking at real-world problems, one of the big challenges is the lack of data or the lack of quality data, right? You're talking about the kinds of environments where we're focused at the IDB and where our listeners are focused, low and middle income countries, low resource, rural settings. So there's a lot of potential and promise that, hey, we can use these AI tools for education, for health services in places that really don't have access today. And that's really exciting. But on the other hand, as I read through the many different applications that are described in the book, it seems like access to the right data is a really key issue that needs to get addressed and addressed early. Tell me about how that has evolved. Is it fair to say that these are circumstances where, unlike the Seattle Children's Hospital example, where there just isn't as much quality data that's labeled appropriately, that this is kind of a major stumbling block before the global development space can adopt AI at the kind of pace and scale it's being adopted elsewhere?
Majority of the projects fail because there's no data. Either there's no data or the data does not have the quality. So data is the fundamental part of any project we work. And I say there are two areas there where we are making a dent and two big lessons learned. The first one is you cannot solve all the problems with satellite data, but if you can solve a problem with satellite data, you know that you will have access to the data and it will scale globally, correct? So that has been a focus a lot, and you will see that in the book, where we have like this idea that let's try to focus on problems we know we have data. So, for example, there was a few years ago, the Nature Conservancy group wanted to understand the landscape of solar farms and wind farms across the world and what was there before. It's like, let's try to see if we can see this from space. Some people have tried to do it. We partner with Planet Labs. They have like this amazing data set that has a picture of every square meter in the world every day. And we realized that we could solve that problem using satellite data. And it's like, hey, okay, now we know our first project was in India, but we knew that after we finish India, it's like, hey, we can do the whole world now. Long story short, I think it's important to know that satellite data provides an amazing opportunity to help with some of these problems. It's not going to solve all these problems, but you know that if you can solve with satellite data, it will scale globally, which is great.
It's funny to think that satellite data is actually the low-hanging fruit in this space in a way, because you don't have to deal with the on-the-ground complexities, right? You don't have to deal with the local issues with people. Essentially, you can take the picture from high up, and you can use an AI tool that can recognize, let's say, a solar panel and determine whether there's a solar farm there at a scale that people can't. So that is a fascinating point. I guess at some stage, though, you reach the limits of what you can do from the sky, right? And you got to get down to the ground level. And when I think of some of the biggest opportunities, in the healthcare space, a lot of it comes down to the massive disparity in trained healthcare workers between low resource countries and high resource countries. And that's not something, you can set up universities, you can try to train people. This is going to take many, many years, if ever, to close the gap because it's so big. And that's where people get excited about AI. I interviewed Vinod Khosla on this point, and he felt like, hey, there's a real opportunity here But this gets messier because now you've got to get into the on the ground examples. And I know there's at least one in your book where you talk about an eye disease, an eye disorder for premature infants, and how you can, use a relatively simple tool in a smartphone to diagnose it early enough that you could provide treatment. So tell me about the healthcare space in general. I know your co-editor focuses a lot on that area, but give us a sense of what you think is possible.
I think it provides an amazing opportunity. I think we need to recognize that we live in a world where 4 billion people, like half of the world, do not have access to doctors. It's not physically possible to have doctors distribute to some of these problems. Like the example I have in the book is retinopathy of prematurity. This is one of the leading causes of blindness in children around the world. It's also a disease that didn't exist a few decades ago, and now we're seeing an exponential growth in many countries, particularly affecting the global south.
And this is largely because infants now are surviving, right? It's great news.
Correct.
Premature infants can survive, but now as a result, you have a higher proportion that are affected by this eye disease.
And we expect, because we also expect continuous improvements in healthcare, that there will be more and more of these premature babies that will survive. So the world has only 200,000 ophthalmologists, but from these 200,000 ophthalmologists, you have 10,000 that are pediatric ophthalmologists. You have millions of babies being born premature every year. So even if you were able to do some magic and distribute these doctors exactly to the distribution of the population that is affected, it's physically impossible. Even if they do that 24/7 every day, there will not be enough doctors to help diagnose this disease. And what we want tools to help doing diagnosis. We want the doctors to be able to do surgery and focus on what we need to do to save these children, like the ability to see. And like that, there are many other problems. What we need to make sure is that in order for us to help the world, we need to have the technology to help these doctors augment the possibility for these doctors to have an impact. This technology doesn't replace the doctors. What this technology can do is make sure the doctor is focused on what they are best for, and use this technology to help augment the capabilities that these doctors have, and focus on the cases that are the ones that they need to focus. Health and healthcare are clearly a very important area for me. I'm very passionate about this because I see huge disparities, and I also see this AI is not just a solution, but it's also the only solution we have.
Well, and the vision of community healthcare workers, and there are many community healthcare workers in places where there aren't enough doctors or nurses, but those healthcare workers with a smartphone, which has connectivity, which can therefore become a diagnosis tool, upload images to the cloud, use AI tools to more quickly triage patients, get them to the care that they need without going through a traditional healthcare system. That is really promising and exciting, but it does run up against all of those challenges that you mentioned earlier, that you learned a lot about at the IDB and that you mentioned in the book, that the real world problems are more human problems. It's not necessarily the technology so much, but really understanding why these challenges exist to begin with, and how you can work with the local organizations, with communities, to design solutions that are actually practical in context. And I guess what I'd love to hear you say a little bit about is, I think about this work you're doing at your lab, and I think about how AI is galloping forward. There's so many billions of dollars of investment. It's clear we're going to make a lot more progress. At least everyone seems to think that. So the tools and the capabilities will grow very fast. But how do we ensure that those tools and capabilities get applied to exactly the kind of problems you're working on at Microsoft? And what would you think for institutions like the IDB or the World Bank or the nonprofit community? Like what can or should they be doing now, given this moment around AI? What should they do differently?
We have very intelligent people distributed around the world, correct? So some of the people that, for example, on the case of the retinopathy of prematurity, I'm working with these amazing doctors in Mexico, in Colombia, and Argentina. They have dedicated their life to help make sure that there's no blind kids. And they're extremely intelligent, extremely passionate. What we want is to make sure that they have opportunities to have that impact, correct? There's 2.4 billion people in the world that do not have access to doctors, but have a smartphone, correct? So roughly, you have 50% of the world do not have access to doctors, 80% of the world have a smartphone, correct? And I think that provides an amazing opportunity, that if any person in the world that has access to smartphone, now will have the capabilities to use. It's not going to replace all the heavy machinery, but it's like a smartphone has an amazing power, like has an amazing processor, has cameras, has sensors. And so I think that's the place where I see more opportunities. But particularly related to your question about what these organizations can do, I think that anything we can do to help people on the ground have the opportunity either to have like access to the internet, have training, have like anything we can help them become self-sufficient in many ways from a technology perspective will always help.
Yeah, you mentioned an example in the book that and I think these examples in general are so helpful to just open people's minds about what's possible. You talk about how, in trying to measure biodiversity, you've used AI tools to listen, like essentially to do what you're calling bioacoustics, to listen to the sounds made by different species in an environment. And it's the kind of thing that, okay, the ability to record those sounds has existed for a long time, but who would listen to them and who would distinguish them and who would measure what does that mean in terms of their relative population? That's a problem that's beyond human ability unless you had some insane number of people trained on doing this at some crazy cost. But for an AI tool, it's possible, right?
Yeah, and that's exactly right. Like people have been using acoustic data for some time, and you have experts, and they work. They are some of our partners, amazing people that understand. Like they can listen to a recording and say, "This is this type of monkey. This is this type of bird." Even if like if I give it to you, it's like this is just noise from a jungle, basically, right? But they can distinguish, and but there's very small amount of people like that, and it takes a significant amount of effort to train them. What we can do is we can help like use some of these, like use their expertise to label data, and then just run these AI models on top of all the data that have been collected. And we're working with the Humboldt Institute in Colombia and for the understanding the Amazon and the health of the Amazon. And they have recordings in 1992, so they have like here, and these like you said, these recordings are recording every day, every single day, like they have like millions of hours being recorded, correct? So it would be almost impossible to go through those recordings. Now, all you need to do is upload them to the cloud and just run these AI models on top of that and get those results, basically.
Yeah, that's an incredible example of what is possible. And also, like, I think how people have to think differently now in the social goods space to try to find what maybe normally would have seemed so out of reach that we wouldn't have considered it in the solution set. But now, if you can say, well, it's relatively inexpensive, and I guess the cost here is more going to be around things like data collection, doing it right, and validating the data. And then, of course, getting some access to data scientists and data engineers to help prepare that data for use by tools. But a lot of those tools will be, correct me if I'm wrong, but they'll be developed by labs like yours. They'll be available free or cheap. Those won't be the barriers. Is that a fair way to think about
At
this?
least that's our hope for two reasons. First, in order to work in majority of these problems, you require coding skills, correct? And roughly less than 0.5% of the world have coding skills, and that number hasn't dramatically changed over the years. We don't expect a huge change. But through large language models, now we have the ability to use our natural language, whether that's English, Spanish, or Mandarin, or any other language, to convert our natural language into coding. We are already seeing that, but in the next years, we will see many more tools that will allow people to code in their natural language. It will still be coding in many ways, but now they will have the ability to code in a language that they speak and not necessarily a programming language. People will still need coding, by the way. There was some debates whether people will no longer need coding. No, coding is still needed. But what will happen is we will have another level of abstraction that will be our natural language being converted into coding, and that will help many more people automate, many more people to code. And through coding, many more people to run these experiments. You will still need a data scientist. Our hope is that there will be more data scientists. Our hope is like all of our partners are people that are experts and like they understand the data, they understand the process, they understand the acoustic, they understand like the problem. Usually what they don't have is the tools to work with the data they collect, correct? And what we hope is that through this type of new technology, they can use their natural language to do the work that they need, that right now they're doing with us. So our success is make sure that we don't have customers. Likely that will not happen, but like our hope is that many more of these researchers or people around the world have access to this technology and can use AI to help them analyze and solve the problems.
Let me probe you a little bit on this point about coders and kind of what the future is. Obviously, this is a broad topic, but it's relevant, I think, for a lot of the context we're interested in at DevX, just because, you know, this is one of those areas like doctors, like educators, where maybe there is a shortage of the human resource of coders in a lot of these countries. And here's an opportunity that might change that. It seems like right now, to be a coder, you need to have the ability to think really logically and break down a problem into many steps. But then you also need to know essentially like another language. And those languages have gotten easier over time, and they've gotten, more closer to a more natural language, and even have sometimes a graphical interface that's a little bit easier to work with. But if we really are going to make this big step that a lot of people are predicting, where you could just talk to a device and get it to develop for you a website or something, then all you would need, I guess, is the logical thinking skill. And that should open up coding as a profession, right, to many millions more people. Is that how you're looking at it too?
That's exactly how I'm looking for. So two things. You will still need coders. You will still need like coding will still be needed. But what people that understand the logic that will be easier for people to understand, they will be able to code. Through natural language, they will be able to convert, but they will still need the coding skills. They will be coding in a different language that is their language, correct? So people will no longer, it's like a lot of the barriers, like you mentioned, is people learning C or Pascal or Python or Java. This is like learning another language, correct? And some that takes efforts, take time. There's a lot of goodness about learning another language, not just like a human language, but like a programming language. But what this will allow is this will allow them to use their language. They will still need the concept of coding. That will still be there. But it will be easier to interact. And right now, like even myself, I use this to generate code every day, correct? Because it's much easier, correct? Like you can say, hey, I need to solve this particular problem. Give me an example of code. I get the coding. Oh, this is how we do it. So cut and paste, put it there. It works. So that provides an amazing power to any developer. But eventually, I want this to not just for the developers, but also for the non-developers to be able to use it.
Yeah, there's a lot of concern that this kind of efficiency gain will lead to tremendous disruption in labor markets, right? And a lot of people will lose their jobs, and other people will become much more productive. And that's a big debate, of course, and it's largely a debate, I think, in rich countries, because there's a lot of thought that it's trained white collar professionals that might get disrupted, accountants and lawyers and professions like that. Um, what's your take on the context where a lot of your work takes place, and a lot of where the IDB's work takes place, where you used to be? What do you think the impacts could be, in particular, in some of the low and middle income countries?
So two things. First, to your first premise, technology has been a net creator of jobs, correct? For the last 150 years, uh, every piece of technology have been a net creator of jobs. As a society, we've been using AI for the last 30 years. And if anything, we actually need more software developers and more people today working on these. There has been some jobs, like you don't see a lot of people that manage elevators, if you ask me today, correct? There are jobs that technology has changed, and we as a society we need to be understand those problems. But the human brain is amazing, and we can use it for solving many problems. Running an elevator, I don't think is one that I would consider one that is needed. Like there, for the amount of problems that we have there, we would love to have the collective human power to solve some of those problems. So, what we see is that there is a lot of opportunities out there, and huge opportunities out there, and we live in a world that still have a lot of disparities. Correctly, you have 6 million children die every year before the fifth birthday. You have 160 million every year that people are affected by climate. You have 1.6 billion people that live with a disability. The world needs all the help it can get, and technology will be able to help. We do, as a society, we need to understand that some of this technology will have an impact, and we need to understand that impact. But we also need to understand that if we can learn something from history, is that the technology it has been a net creator of jobs, and I haven't seen things where that trend will change.
I feel like the book, it's technical in nature, but it's still also very accessible. I mean, you start with a primer about what is AI, you kind of take readers through some of the very basics, and then it's really mostly filled with these examples, across sustainability and health that you talked about, using satellite data. There's a lot of examples like that. What Maybe you could just talk for a minute about why you decided to put out this book. I mean, the timing is sort of amazing given what's happening in the AI space and the questions people are asking about precisely what can you do with it for positive things. What was your goal by putting this book out at this point?
I think it was a lesson learned from working with these organizations. We realized early on that the best way we could have an impact with these organizations is to help them understand the power of AI. Because in order for them to solve a problem, we needed the organizations to understand how they could use AI. And we didn't know what problem they were trying to solve. What worked very well was showing them examples of other projects that we have solved with AI. And through those examples, they said, oh, you're actually using this data for this. We could do that. Like one of the best examples I have for that was one of the early acoustic data projects we had was underwater sensors working with NOAA to detect beluga whales. And we showed these to a nonprofit organization that was trying to help other nonprofit organizations collect evidence of war crimes in Syria. And they saw that and say, could you use the same acoustic data model to detect specific weapons that are not allowed by the Geneva Convention? And we didn't know that, but we say, as long as that weapon has a specific sound fingerprint, the answer is likely yes. And this was cluster munition. Cluster munition is one of the weapons that is banned by the Geneva Convention, and it has a very particular sound because, like, tick, 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 like it's a very particular sound. That is something that would have never been in a conversation if it wasn't because we actually showed them an example of a problem that had nothing to do with the problem that they're working on. But they realized that we could analyze acoustic data and solve problems. So for us, it became really important to showcase what problems could we solve with AI because we want these organizations to think if you solve that problem, we can solve this particular problem that I have. And that's why we wrote the book, was to have a good examples for these practitioners to say what problems can you solve using AI. It's 30 chapters, each chapter is a different problem. And our hope is people can read these chapters and say, oh, if you solve this, I could potentially solve my problem too.
I think it's a great mission for the book, and I'm sure it will come to pass. And I feel like one of the key themes in the book will also maybe change people's mindset, which is to bring in the AI and the AI expertise, but also bring in the partner and local expertise at the same time, right at the beginning of trying to solve the problem. And you kind of come back to that over and over in the book, that this is not something where you can bring in, the technical expertise later, nor can the technical experts start working on this and then later reveal it, to the partner organization. It has to be truly a hand in glove effort.
Yeah, and that's right. For us, it's really important. We don't work in projects if we don't have a partner on the other side. As a computer engineers, we usually have that bias that we want to go and solve problems, but we need to recognize that a lot of these problems are not just applying data and applying algorithms and trying to solve it because it's not going to work. Majority of the problems are outside that. That's why it's critical to create these teams that combine the subject matter experts with the AI experts and work together to solve the problem. That is critical. Like if you ask me, like what I hope that come across in the book is that don't go and just try to solve the problem yourself. Partner with people that understand the problem, understand the data, and then work together with them to solve them.
You've been working, Juan, just as we wrap up, you've been working on machine learning and AI for a long time. You talked about your role at the IDB earlier in your career. There's a lot of hype about AI now. Is your sense that this is truly a different moment, not just for AI, but for AI for good? Meaning if we get together a few years from now, that this will have been this inflection point in terms of what we can do with the limited resources that we have to actually make the world a better place?
There is clearly hype. We have to recognize that we are in the hype cycle in many ways, but we also need to understand that some of that is based on real things, is that there is a shift. And these large language models provide amazing opportunities. It's an amazing tool that we didn't have before. And now the fact that we have millions of people around the world interacting with AI, similar to what computer science were doing already, but computer science is a very tiny portion of the world. Now the people around the world are using this technology and have the ability to code and have the, like code in their terms, have the ability to interact with AI that before they couldn't. So this provides an amazing power, and that power is real. We also need to understand that we still, there is some hype around this. I think that that will pass, meaning that people will later on recognize what is true, what is real, what is not real, what problems can we solve now, what problems we will not be able to solve with these tools. But clearly there has been a step function that I wasn't expecting to see in my career. If you had asked me 10 years ago whether I would believe that there was a model like GPT-4 with the power that GPT-4 has today, the answer is likely not. But I'm very excited. I think it's an amazing opportunity to help the world. And like I mentioned, I think people need to recognize that there are still a huge amount of problems in the world that we can help solve. And my hope is we will have many more people trying to help solve some of these problems.
It's an important message and an important time to have this conversation with you, Juan Lavista Ferres. Thank you for taking the time. Thank you for writing the book. And thanks for being here on the DevX Book Club podcast.
Thank you, Ryan. Thank you for inviting me, and a pleasure to see you again.
Juan Lavista Ferres is the Corporate Vice President and Chief Data Scientist at Microsoft's AI for Good Lab and the co-editor of the recent book, AI for Good: Applications in Sustainability, Humanitarian Action, and Health. You can follow him on social media at @BDataScientist. The DevX Book Club is produced by Lauren Evans. Our executive producer is Margaret Richardson, with assistance from Valeria del Castillo. Thank you all for joining. If you like the podcast, please share with your friends and give us 5 stars. And we really do want to hear from you. Please leave your thoughts in the comments or send me a message on Twitter at Raj_DevX. To learn what we're reading next, make suggestions for future guests, or submit questions for authors, be sure to sign up for our DevX Book Club mailing list, which you can find in the description of the show wherever you're listening to this. If you care about global development issues and you want the latest news, don't forget to subscribe to the DevX Newswire at the link in the comments, where you'll get the day's top global development breaking news, analysis, and opinion, as well as the date of the next book club. Until then, do good out there, and thanks for joining.